Hello, it's been a long time since my last videos. I miss you a lot. Mm, Today I read something about the data analytics and something about big data. The data analytics, the data analytics tools can be grouped into two separate areas. First is explanatory analytics. The second is predictive analytics. The explanatory analytics more focuses on the history data, the past data, and the current data. Like, do they have any relationships or trends or some patterns in some dimensions? By some dimensions, while the predictive analytics more focuses on predicting the future data outcomes according to the data we have. The explanatory analytics. An example of that is data mining. The data mining has four phases. The first is data general preparation and data analysis and classification. The third is knowledge acquisition, and the fourth is prognosis. When we do data preparation, like the main data size, the main data size is identified and cleansed of any data impurities. Because we use the data the data we use is from data warehouse, and you know that the data warehouse the data warehouse by the has already integrate and filter the data, so our data is cleaned already, so we don't have to do anything special. The second phase is the data analysis and classification. In that phase, we'll do some groupings, classification, or some aggregations, and we need to find some data dependencies, some links or relationships, and figure out some patterns, trends, or some deviations. The third phase is the knowledge acquisition phase. We want to generate some knowledge out of our patterns and trends or some deviations. The most common algorithms we use to acquire the knowledge are based on neural networks, decision trees, genetic algorithms, classification and regression trees, and nearest neighbors. I think the last phase, the prognosis phase, is more like some predictions. Also, data mining is more focuses data mining focuses on explanatory analytics. There could be some prediction part, yes. When it comes to the predictive analytics, it could also be some mathematical, statistical algorithms, some neural networks, artificial intelligence, or other advanced modeling tools or even LLM to help us to do some predictive analytics. Yes. Let's continue. Then the book tells me something about the SQL extensions on some analytics function, like the rollup extension. Like when we do some group by, the rollup will tell us the partial subtotals. Like if it's pure group by, we can only get like we will only get a grand total. If we want to group by column A and column B, we'll get a grand total of all the like the unique combination of column A and B, but we also sometimes we want to get a partial total, like what if column A equals to 1? What is the subtotal of column A equals to 1? And what is the subtotal of columns A equals to 2? We won't get that if we just do group by column A and column B. But when we do group by roll up, it will automatically generate the subtotal by column A. Yeah, it's not a special idea. It's not a like how to say, it's not an innovative idea, but it's interesting. Then it's about the queue extension. I have mentioned that the roll up, like when we do group by column A and column B, it will show column A. But what if it is a partial command, like it has orders? When we say group by column A and column B, it will only show the partial subtotal by column A. But the group by cube command will show all the partials, all the possible partials. When we say group by cube column A and column B, it will first show the subtotals by column A and then show the subtotals by column B. And finally, it will show a grand total by column A and column B. Yeah, it is also not a very new idea, very like creative idea, but it's fine. Finally, it's the materialized views. Yeah, we all know that the materialized views create materialized views will name views immediate or deferred. Refresh, we can refresh it fast, complete, or false. And it will enable query write as select query. I think like materialized views is something the DBMS used it to speed up its processing. When user didn't use it intentionally. We user didn't use it intentionally. It still helps with something, and we user can set it refresh like fast or complete or false. When we refresh it fast, every time we change something, we will refresh the view. When we set it complete, I think like fast is something like we only update any part that is affected by one transaction. But when we do it like refresh complete, we'll completely rebuild the views and every time we update something. Fourth is like the DBMS will first try to do a fast update, otherwise it will do a complete update. Yeah. Let's go on. Data visualization. I think it's a big science discipline. It is a discipline. It's a big science topic. Like how to make our visualization more comfortable when human look at our visualization. Yeah, it's something like related to cognitive science or like neuroscience or some anthropology. A very easy to understand example is that when we want to count the number of soccer balls, how many soccer balls are there? Assume there are nine soccer balls. The panel A is like the nine soccer balls in a row. We need to count it one by one. While panel B is like there are three groups of soccer balls. Each group has 3 soccer balls, so that we can count it by 3 times 3. It's more easy for our human to count the second example. Like our brain is wired in a way that make it quicker to process data when presented with grouped objects. Yeah. We are it's more easy for our brain to process the grouped objects instead of just one by one in a row. So it's also this could be applied in like data visualization. We need to like carefully deal with like pattern recognition, spatial awareness, as well as like aesthetics. As these are 3 most important parts in data visualization. Finally is the like we should understand the data type. In general, there are 2 types of data. First is qualitative, like describes the qualities of data. This type of data could be subdivided into 2 subtypes. One is nominal. Nominal data can be counted but is not ordered. Like the sex, we have biological gender, male or female. They can be counted, but we cannot say that male is larger than female or female is larger than male. They cannot be compared. Like just the 2 labels, they cannot be compared. And the student class, like we can have graduate student or undergraduate student. Yeah, we cannot say that like graduate is superior than undergraduate. Yeah, it's nominal data. There could also be ordinal data that they can be counted and ordered, but they cannot be aggregated. Like for example, when you rate your teacher, you can rate your teacher as excellent, good, fair, or poor. Like when we want to, so what is your family income? Like you can be under 20,000 to 40,000, 40,000 to 60,000, or over 60,000. Yeah, these are we can figure out the orders in these examples.